All right, hello there. We've got Methods Exam 1 from 2022 today. So question 1 is differentiation, and we have a product rule to start with. So we have u equals 3x, derivative of u equals 3, v equals e to the 2x, and the derivative of v is 2e to the 2x. And dy dx will be uv plus uv, dashes on the edges. So that is going to equal, label this properly, we've got dy dx equals 3e to the 2x plus 6x e to the 2x. And that one's done. Part B, we have quotient rule. So I'm going to lay this one out the same again. U equals cos x. The derivative of u equals negative sine x. V equals e to the x. Derivative of v is e to the x. So f dash of x equals uv minus uv dashes on the edges over v squared. So that will equal negative sine x e to the x minus cos x e to the x. And all of that is over e to the x squared, which is e to the 2x. And we're asked to simplify. So I will factor out e to the x and then use index laws to cancel one of them out. So you end up with negative sine x plus cos x all over e to the x. There's question 1 done. Question number 2, find the rule and an antiderivative for g of x. Now notice here it says an antiderivative, so we don't need to worry about plus c because c could equal 0. So here from the formula sheet you'll see these sort of 1 on x turns into log x, but I do need to have f dash of x divided by f of x. So the derivative here is 2, so I need a 2 on the top and not 3. So I'm going to put a 2 out here, and the 3 will come out the front as a coefficient, and since I've multiplied by 2, I'll divide by 2 to cancel that out. Dx. And now I have f of x on the denominator and the derivative on the numerator. So all these coefficients, they can come out the front. And then we're left with 3 over 2 log e of 2x minus 3. Be very careful when writing log e. We don't want to see Loge written down. You want to make an effort to put the e down the bottom. All right, next one. Evaluate this one. So first step, let's use some expansion to expand this one out. So we've got the integral from 0 to 1 of 2 f of x all squared minus 3 f of x dx. And then we can split up our integrals here. So that's going to become the integral from 0 to 1 of 2 times f of x squared dx. And I'll bring the 2 out the front, in fact. Minus 3 times the integral from 0 to 1 of f of x dx. And now I'll substitute these in. So the first one we've got f of x all squared is 1/5, and then f of x is 1/3. So 2 times 1/5 minus 3 times 1/3. So 2/5 minus 1, negative 3/5. Next question. Consider the system of equations. Determine the value for k for which the system of equations have infinite number of solutions. So infinite number of solutions is saying to us that they are the same rule, basically, or the same equation. So we want these in the form y equals mx plus c, and I'll put both equations in that form. So the first one, I'll move the kx over, so negative 5y equals negative kx plus 4 plus k. Then I'll divide by negative 5, so y equals kx minus 4 minus k, all divided by 5. Okay, and for the second rule, same thing, transpose this to get y. So k plus 8y equals negative 3x minus 1. Y equals negative 3x minus 1 over k plus 8. And now I've done this, I want to have the same rule so I can equate coefficients. So I need the m, which is this, to equal the m on this rule as well. So we're left with k over 5 equals negative 3 over k plus 8. Now I have a quadratic. So k bracket k plus 8 equals negative 15. K squared plus 8k plus 15 equals 0. K plus 3, k plus 5 equals 0. So k equals negative 3, k equals negative 5. Now from here you can substitute these back in to equate the coefficients of the constant, or you can do the same process for the constant. So now we're going to equate coefficients of the constant here and here. Okay, but you might be more comfortable with substituting. I'm going to equate coefficients. So I've now got negative 1 over k plus 8 equals negative 4 minus k over 5. We have another quadratic, minus 5 equals k plus 8. Negative, bring the negative out the front. And then k plus 4. So the negatives cancel with each other. And then I have 0 equals k squared plus 12k plus 32 minus 5, so plus 27. So 0 equals k plus 3, k plus 9, so k equals negative 3, k equals negative 9. So the only one that is true in both of them is the negative 3. So there's our only solution, k equals negative 3. Next question. A card is drawn from a deck of red and blue cards. After verifying each colour, the card is replaced. Very important, we identify there that the card is replaced. And this is performed 4 times. Each card has a probability of half being red, half being blue. A colour may be, the colour of any drawn card is independent of any other card, okay? Let X be the random variable, the number of blue cards in the deck. Complete the table. So we can do the binomial formula to work out each of these X values, or we can use symmetry to see here that the probability of getting all blue is going to be the same as getting all red. So this one here is also 1 over 16. And we'll continue using symmetry. All of this has to add up to 1. So far I've used 8 on 16. So there is 8 on 16 left, 4 each. 4 on 16, 4 on 16. Given that the first card is blue, find the probability of exactly 2 of the next 3 cards will be red. This is interesting because the cards are being replaced. So it actually doesn't matter that the first card is blue. The card got replaced. So this is the same as just pretending that we're drawing 3 cards. So we're doing exactly 2 will be red. That's going to be, now they have the same probability, so it really doesn't matter. So we got 3 combination 2 of 0.5 squared times 0.5 to the power of 1. So that equals 3 times a half cubed, which equals 3 over 8. Next one, the deck has changed so the probability of a card being red is 2/3 and the probability of a card being blue is 1/3. Given that the first card is blue, so again, this is not relevant. The card got replaced. Find the probability that 2 of the next 3 cards will be red. So red is 2/3. So the same thing, 3 combination 2. Probability of success is 2/3. We want 2 of those. Probability of a failure is 1/3. We want 1 of those. So that's going to be 3 times 4 over 9. 4 over 27. 3 times 4 over 27, which equals 4 over 9. All right, so interesting question. We've got this conditional probability, which is irrelevant because the cards were getting replaced. Moving on. Very easy, question 5 here. We are going to make the bases be the same and then equate the powers. So 100 is 10 squared. So we got 10 to the 3x minus 13 equals 10 squared. So therefore 3x minus 13 equals 2. So plus 13 is 15, divided by 3 is 5. X equals 5. Find the maximum domain of f, where f of x is this log. Now we know the logarithms have to be greater, the argument of the logarithm must be greater than 0. We can't log 0 and we can't log negative numbers. So that means the argument, which is this quadratic, x squared minus 2x minus 3 is greater than 0. Let's factorize this. X minus 3, x plus 1, greater than 0. Now, whenever we're doing inequalities, I recommend sketching. So, throw a quick one up here. We're crossing through a -1 and 3. So, where is it greater than 0? It's greater than 0 in this region and this region. So, x is an element of negative infinity up to -1 in union with, make a bit more space here. So x is an element of negative infinity to -1 union 3 to infinity. There we go. Okay. It's greater than, so we're not going to include the 0 points. Question 6. On the axis above, draw the graph of g of x, where g of x is the reflection. So we're reflecting across the axis here. So what I recommend doing is taking all the critical points and reflecting those and then connecting the dots. So the starting point, -1, will go to 1. Local max becomes a local min, so 1 becomes -1. The zeros are going to be the same. 0 reflected is still 0. So let's put these ones in. And then negative 3 will come up to positive 3. 1 goes to negative 1. And negative 3 goes to 3. And the endpoint of negative 1 goes to 1. So now I'll connect the dots. And there we go. I've drawn that reflection. Find all the values of k such that f of k equals 0. So this would be the same as if it was f of x, they're just replacing x with k. So we're going to use our equation from up here. And k is between 0 and 2 pi. So replace x with k, we end up with 0 equals 2 sine 2k minus 1. Now when we're solving trig, there's a few ways to do it, but I like to compare what's inside the function with our domain. So I've got 2k here, but my domain is k. So let's transform the domain. 2k is an element of 0 to 4 pi. That will help me find all my solutions. So now I'm going to solve this. We get 1/2 equals sine 2k. So from here, we use unit circle. We want half, so that will be here and here, which is pi on 6, 5 pi on 6. And this is where my domain comes in handy. For 2k, it's going to be 2 trips around the circle. So I'm also going to get 13 pi on 6 and 17 pi on 6. So 2k is equal to pi on 6, 5 pi on 6, 13 pi on 6, 17 pi on 6. So then solving for k, k will equal pi on 12, 5 pi on 12, 13 pi on 12, and 17 pi on 12. And then we just double check that these solutions fit back in this domain, which they do. So now we've got a new function h, where h of x is the same rule as f of x, but with a different domain. The graph for h of x is translated a units in the positive horizontal and b units in the positive vertical direction, such that it becomes g of x, where g of x was our reflection. So we're saying what is happening to f of x? How can we translate f of x to become g of x? So if we come and have a look over here, here's f of x, and I want to translate it such some amount horizontally and some amount vertically, such that we end up at g of x. So the vertical translation is 2, because we're going from 1 to 3. That's easy to see. And using the grid lines, we can see if this is pi here, this is a 1/2 pi. So this is a 1/4 pi, and this is 3/4 pi. So we're going from 1/4 to 3/4, so we're adding a 1/2 pi. So come back down here. What is the value for b? B was the vertical, so b got moved up 2. And the smallest positive value for a, they say smallest because technically with trig, I could translate, infinite number of times. So this point here could be translated all the way up to this point up here, or even further. But the smallest possible, we've seen that was pi on 2. Hence or otherwise state the domain for D. Now, whenever we see hence, we want to be using the previous information. So it's something to do with pi on 2 here. Find the domain of D. find the domain D, which is this one up here of h of x. So our original function is translated some amount so that it becomes g of x, and g of x starts at 0. So if g of x starts at 0 and our function h of x is translated to become g of x, h of x must have came from over here. It got translated to then start at 0. And how much was translated? Pi on 2. So our domain must be negative pi on 2 to 3 pi on 2. Such that when I add pi on 2 to this domain, I end up with a domain of 0 to 2 pi. Okay. Next question. So, find the area of the front surface of each tile. Now, we've got here, the tiles are 20 by 20. And here is the front section, shown below. So, the area is going to be 20 centimeters by 20 centimeters, which is 400 centimeters squared. Now, there's some conditions here. So each color covers half the tile, and the tiles are lined up so that they're a continuous pattern. So if it's going to cover half, we've got type A. Type A is this function here. So we're basically asking, what is the value of A such that the function covers half? Now, sine is symmetrical, so for it to cover half, we want it to be halfway up the tile. The tile is 20 centimeters on the side, so it must be 10. Okay. Not too bad. One thing to note here, this continuous, not to be confused with when is a function differentiable. So we're not looking at discontinuity of functions in calculus here. It just means is the tile connecting from here to here. So type B tiles, an example, which of the following shown are divided using this rule. So show that type B meets condition 1. Now condition 1 is that each color covers half the tile. So we want the area below this curve to equal a half of 400. So the area is found using calculus, 0 to 20 of g of x dx. That is going to equal, so x cubed becomes x to the 4 divided by 400. So negative 1 over 400 x to the 4 plus x cubed divided by 3. So 1 over 10, because the 3's cancel, x cubed, minus 2x squared divided by 2 plus 10x. From 20 to 0. The 0 is very easy. We can sub that in, everything will be 0. So we sub in the 20. Now 20 squared is 400. So the 400s will cancel, and I'm left with 20 squared again, which is negative 400. So negative 400 plus 20 cubed is 8,000 divided by 10, so 800. Minus x squared, so minus 400. Plus 10x, so plus 20. That equals 200 centimeters squared. And 200 is equal to a half times 400. So that's shown. Determine the endpoints of f of x and g of x. So f of 20 equals 4 sine pi times 20 over 10 plus 10. 4 sine 2 pi plus 10, which equals 10. Sine of 2 pi is 0. And g of 20 is equal to negative 1 over 100 times 20 cubed plus 3 over 10 20 squared minus 40 plus 10. So again, we've got 8,000 over 100, so negative 80 plus 120 minus 40 plus 10. That's 120 minus 120, so that's also equal to 10. Hence, use these values to confirm type A and type B can be placed in a continuous pattern. So g of 0 is also equal to 10. G of 0 equals 10, and f of 0 also equals 10. So therefore we've got f of 0 equals g of 20, which equals f of 20, which is also g of 0. Doesn't matter the order, but that's shown as required. Done. Question 8. State the value of a of pi on 3. So we'll sub pi on 3 into a of k. We get pi on 3 sine of pi on 3, which is sine of pi on 3 is root 3 over 2. So we've got root 3 pi over 6. Evaluate f of pi on 3. Now, the integral of f of x dx is equal to the area of x. So then therefore the derivative of the area is going to be the function. So the derivative with respect to x of x sine x, using product rule, sine x plus x cos x, and then we can sub in pi on 3. So f of pi on 3 is equal to sine of pi on 3 plus pi on 3 cosine of pi on 3. So root 3 over 2 plus pi on 6. Pi on 3 times a half is pi on 6. Consider the average value, not to be mistaken with average rate of change. We've got average value here. So the formula for average value is the integral with 1 divided by the domain. And we're going for a domain here of 0 to k. So k minus 0. 0 to k. Of the function f over the interval. So over f of x dx. Now we cannot integrate f of x, but we can use a relationship from up here. So we know that equals a of x. So that's going to be 1 divided by k multiplied by a of x from k to 0. So we end up with now a of 0 will be 0 because here. So we're just left with 1 over k, a of k, which will be sine k. Then we're asked to find the value of k that results in a maximum average value. So what value results in sine being at a maximum? That is pi on 2. So that's the exam. Thanks for watching. Hope this helped. See you next time.